Well, thank you all so much for coming. This is our second session, and we're going to do TigerGraph's Introduction to Graph and Application Supply Session, Supply Chains. And Dan Barkus is going to be in charge of this session. He's our developer advocate. He's wonderful at this. And before he gets going, I want to introduce Jeff because he has a special place for you all.
Yeah, hi everyone. My name is Jeff Tizer. I'm a sales engineer at TigerGraph, and I was a student in the master's program about 10 years ago and graduated with an MSIQ, and I've had to maintain a relationship with the school ever since. It's the program, the school, and Dr. Talbert in particular are near and dear to my heart, and I'm so glad that we have this opportunity to talk to you all again.
Thank you. And Dr. Talbert, do you want to say anything before we hand it over to Dan? You're on mute, so I can't hear you.
Sorry about that. So yeah, I just wanted to reinforce what Jeff was saying. I think it's a great relationship. I'm always so pleased to see our students go out and doing so well out in industry. And it's really gratifying to have him come back and help set up this collaboration between our program. As I told him, you all reviewed some of our coursework, and we're a little bit deficient when it comes to graph technology. So this is going to really fill a gap in our curriculum, and I appreciate your help. Thank you.
Our pleasure.
Well, thank you. Yes, and we're excited to work on that, and we'll love your feedback too if you have any. But with that, I'm going to give it over to Dan. I'm going to turn off my camera because of my internet, and thank you all again so much for joining.
Great. Thank you, Kaylee. So I'll go ahead and share this. Let me know if this gets weird when I make it full screen. And if it does, then I will just give it from the view. Does that look fine?
Good. Yeah, looks good.
All right, great. So today I'm going to be introducing using TigerGraph for supply chain management. And we're going to be focusing a little bit on one of our real world use cases and our customer Jaguar Land Rover and how they were able to use TigerGraph to improve the efficiency of their supply chain and to reduce the time it takes to make decisions based around supply chain management. So I guess first, kind of as an intro, I will be showing off one of our TigerGraph starter kits in this demo. And those starter kits you can run for free. So if you are interested at all in setting up a starter kit and kind of following along with the later part of the demo, then please go to tgcloud.io, create an account if you don't already have one, and then I'll walk through kind of how to set up the starter kit and do everything else from there. So if you'd like to participate in the interactive portion of the demo, feel free and go ahead and do that now. You'll just have to confirm your email address, but otherwise everything is entirely free. So a little bit about me. I'm a developer advocate here at TigerGraph. I am mainly in charge of creating educational content and building out tools and connectors to help other people use TigerGraph or integrate it with their existing processes and workflows. Formerly, I came from a company called Optum, which is the tech side of United Health Group. So I worked a lot in the healthcare tech space, and that's kind of where I was introduced to TigerGraph as well. So once again, just kind of as a quick overview of graph databases versus what we're used to, our traditional relational databases. So whereas a traditional database, you have a bunch of tables. Those tables consist of columns and rows. Your columns are kind of the topic of your data, and the row is each one of your particular entries. So you might have, in this example, we have, a table for products. So you would have a list of products, maybe with, product name, product description, product price, something like that. And then you would be able to link those to a table of orders and to a table of suppliers. And there's a lot of these joins that you need to create between these tables to get a holistic idea of your data. Whereas with those joins are kind of built into the graph. So instead of having all these tables that you have to connect to each other, you have nodes and edges. And these nodes and these edges are inherent parts of the graph structure. It's not like a relational database where you create those joins when you write your query. Within a graph, those joins, quote unquote, are called edges, and they're created when you load in your data. So instead of having to do all of this processing when you go to run your query, it's already done for you when you load it in your data. And when you want to now navigate around that data, it's instantaneous because you're just traversing pointers between memory locations. So as a similar aspect, we have nodes, which are analogous to tables in a way. They contain attributes, and those attributes are analogous to your columns. So for each row, you would have a node, and that node would have attributes which pertain to those values associated with the node, and they're all connected. I'll get a little bit more into the graph stuff later, but just know that it is a very easy and fast way to connect disparate data sources to each other via edges and to view the deeper insights that can be generated when that data is connected. And like I said, I'll expand on that a little bit as we move on. So let's kind of focus on the topic at hand, supply chain management and how that worked for Jaguar Land Rover. So I need to set the stage here. What is supply chain management? What is a supply chain? How complex is it? And how does that really fit into a real world area? So when we build something like a car is made up of many different parts. Those parts are made up of like sub-assemblies. Those sub-assemblies are made up of components. Those components have to be purchased from suppliers. And then even more to expand from that, you have suppliers creating components that go into assemblies, that go into larger assemblies, that go into a complete vehicle. You now have different types of vehicles. So there's, whether it's an SUV, a car, a large off-road vehicle, or also there's different trim levels of these vehicles. Does it have a sunroof? Does it have the leather seats? Does it have a heated steering wheel? So now all of a sudden we have all of these different parts that have to come together to form any number of different possible outcomes. So there's just a lot of moving things in there. There's a lot of different components to keep track of. And there's a lot of questions that we really can't answer with just that information. So the way that this had worked at Jaguar Land Rover was they had 12 different data sources containing all of their information across 23 different relational tables. And every time that they wanted to go ahead and update or get new insights from their supply chain, it took them about 3 weeks to answer the questions that they were trying to ask with their current setup. Now, 3 weeks is a long time in the business world. So really, any time that we can make an improvement to that, and 3 weeks, it's very easy to make an improvement to, then that's just free productivity that really frees you up to do other things. So taking a step back, before we can even get to the supply chain, there's sales forecasting. So you need to know how many of each type of car do we need to make every year, or every upcoming year. How well is that model going to sell? How many people do we expect to buy each trim line? All of these different things that you have to bring together 2 to 3 years in advance before you even want to launch a new line of vehicle. So you have to do all of this sales forecasting to plan out your supply chain, because suppliers, people who you're buying parts from, they have quantities. They only have certain quantities that they can give you. So if you need a custom part and you say, I need 10,000 of this custom part, and then later on down the line, you ended up only needing 8,000. Well, the supplier made 10,000, and they're certainly not going to cut the losses on that. You're paying for 10,000, whether you need 10,000 or not. So that supply chain management aspect of things really comes in there. When you're doing this forecasting, you need to be able to predict those numbers. That way, your supply chain can function seamlessly down the line. Now, obviously, because these things are being planned 2 to 3 years in advance, there's a lot of room for things to change. And that's kind of when we enter in late 2019, early 2020, COVID era. We've made these predictions 2 to 3 years down the line, thinking that the world's going to be a perfectly normal place. And now all of a sudden, things are very different. So how do you pivot your supply chain in order to keep up with that changing demand? And now, when it takes 3 weeks to do that, that's a huge process. That's something that, as things are changing on the fly, you don't have the ability to afford 3 weeks every time you need to make a change to your supply chain. You need things to happen quickly. So that's where Graph comes in. So by bringing all of those tables in, all of those different sources, and being able to connect them with these edges rather than having to write these complex queries to join them together, our data is inherently connected within the database. We're now able to write queries and gain insights within 45 minutes rather than 3 weeks. So what used to be a huge effort across multiple teams to put together all this data, to update these supply chains, to get updated readings, is now something that you just click a button and you let it run. And that is a huge increase in value, something where you no longer need to spend people time, you no longer need to spend actual time and money to do something. It's just a query that you run once and you get an update within the hour. That's amazing. So let's take a look at a little bit more of how we can do that and how the supply chain is kind of something that naturally fits into this graph schema. And that's sort of what this is showing, is that our graph, if you remember, is a relationship of nodes and edges. So here we can see that we have orders from people of different types of cars, different trim levels. Each one of those contains different features. So these might be things like I was saying before, a sunroof, a power tailgate, things like that that are optional features, but vary from car model to car model. Each one of those is made up of parts, and all of those parts come from suppliers, and those suppliers may source raw material from other suppliers. So if we need to make a wheel, or a tire, we're going to need rubber, we're going to need steel banding. So there will be a rubber supplier, a steel supplier. The steel will go to a company that makes the banding, and the rubber will probably a tire factory, and that banding and the rubber will come together at the factory to make our tires, and then those get somewhere else to be put on wheels, and then those go to the assembly line to get put on actual cars. So there's all these different steps that we have to take to do this, and because of that, that naturally lends itself to a graph. Supplier makes part goes to other supplier to make other part goes in this trim level of vehicle, and so on and so forth. It's really easy to traverse that chain. Now, as a table, though, this doesn't really work out. You can see that we have all these different tables that then have to be joined to each other, and it's very complex, and there's no real normalization possible, right? So if I want to keep track of all of my parts in one table, I have something like a screw, which may only have information about the number of threads, or the thread count and the length of the screw. But if I have something like a ECU module for my engine, that has a bunch more information that we need to keep track of with it. What is the firmware version that it's running? What is the the connections on it for the car that it goes into? And now I have to have a table that has something like all these different links for info on each one of these specific components. And a lot of these rows are just going to contain blank columns, because a wheel only has info about a wheel, an engine only has info about an engine. So now we have this big sparsely populated table, more or less because we're doing one-hot encoding on it. And that's just not a very efficient way to run things. Why have a big table if most of it's going to be empty? So that's really where Graph can come in to help out, is that instead of having to have this one big table with everything in it, we're able to create these different vertex types within the graph that contain the specific information just relevant to that vertex type. So our engine vertex type only needs to contain info about the engine. Our wheel vertex type only needs to contain info about the wheel. And we're able to easily create those in a flexible manner where they can all be joined together within the graph, much like we were seeing before. Additionally, adding in data in a traditional database is not an easy process, especially if we're following that aforementioned schema where we have each one of these columns kind of for each one of these infos. All right, we've got in standard internal combustion engine, that's what we've been using for all of our engine info. Suddenly we release an electric car. Now we've got an electric engine. All right, so now we need a column for that electric info. So joining that into a pre-existing table, now we have to insert that column. We have to add a bunch of zeros to all of our past data. It's just a big mess. Whereas with Graph, create a new vertex type, add it to the schema, and you're set. You're good to go. You don't need to worry about back updating all of your old data or anything like that, because it is new. And with Graph, it is naturally lends itself to that expandability and the ability to adjust the schema on the fly. Looking at depth. So depth is kind of those from those linkages. How many layers deep do you go? So if you're writing a traditional SQL query, something to traverse maybe 10 tables, say you're looking for something, right? You're looking for a specific part within a vehicle. So you're going to kind of start at that vehicle table and then break that down into each one of those parts. But you don't know where that part is. You don't know if it's a high level assembly, or you don't know if it's an individual component that goes on a circuit board, which goes in a sub-assembly, which goes into a bigger assembly. So you don't know how far you have to traverse through your data when you're writing that query. So writing a traditional join for that, you really have to know exactly what you're looking for when you go to traverse all of those tables. Otherwise, you're not really going to be able to find it. But with TigerGraph, you just say, I want to start here and I want to end here. And the graph does the rest. It's connected by those edges. It can traverse those edges, find the shortest path, find any paths, let you know if there isn't a path there. You know, this part doesn't go in this assembly. Whereas with your traditional query, SQL query, that would be something that's much harder to write and a lot more difficult to gain insights from. Additionally, Graph allows you to do many-to-many links. This is something that is traditionally very tough to do in a relational database, if not impossible. But you can say, you know, I want to link this one vertex to all of these other vertices. All right, just create more edges, no problem. This vertex points to this vertex, which points to this vertex, and so on. And you don't have to worry about having to keep track of potentially an individual entry for each one of those links in your database. It is just, you have one vertex, it has 3 edges coming out of it. It's as easy as that. And traversing that is also just as easy. You just specify which edge you want to traverse, or all of them, depending on the query you're writing, and you're good to go. And then additionally, there's kind of the concept of directionality. So if I go back to this earlier slide here we have these arrows saying, you know, these people are ordering these cars have these features have these parts, right? So this is going from the order down the supply chain. But what if we want to traverse back up the supply chain? How do we do that? How do we say, I want to start with this supplier and I want to know what orders will be affected if that supplier goes out of business or, you know, is unable to provide parts for whatever reason. So now in a traditional sense, you'd have to rewrite all of your queries to go back up the path. You know, you'd have to write this complex query with all these joins to go back up from supplier, and it wouldn't be very flexible because you'd be doing it to check that one thing. Whereas with Graph, we just say, start here, end here, let me know everything in between. There's no need to worry about which direction you're going. I mean, obviously you can specify in your query, but the idea here is that with that initial schema of the graph, everything is very flexible. You want to then be able to go navigate either way. You want to go halfway, you want to go halfway and then back. It doesn't matter. You specify that in your query and you're good to go. So that's kind of what that directionality is touching on. And then sort of to really drive things home with all of these joins that you have to do in a traditional database to go through all of this process, there's all these Cartesian joins. You're essentially going table A all the way to table B, except we'll filter it out and we only want, you know, this bit from table B. So now as you go from table B to table C, you have to then do that again. So you're essentially getting the entirety of all these tables every time you want to, or you're processing the entirety of these tables every time you want to join them together. And that's just a very slow, computationally heavy process. Whereas with Graph, you only ever touch the things that you want to interact with. So if I'm doing something like this, where I want to find, you know, link 4 in this second table, then those are directly connected by an edge. That's the only edge that I traverse. I don't have to worry about what other types of vertices there are of this type, because I only ever see the one that is connected via an edge when I'm performing a query that's looking for that edge. So the same thing here. So instead of interfacing with, you know, there's 6 in each table, instead of 6 in each table. So instead of interfacing with 12 vertices when I want to do my query, now I only interface with the 3 that I actually care about. So it's a huge reduction in the amount of computational power needed to gain these insights, as well as the amount of overhead required when writing those queries in order to get those insights. So that's kind of a very high level of some of the advantages that Graph offers over our traditional SQL way of doing things. So let's hop into the demo now and talk a little bit about what this looks like in the real world and some of the cool insights that we can gain that we either might not have been able to see before or would have been much more complicated to see given a relational structure. Now we're going to head over to tgcloud.io. This is our TigerGraph Cloud portal where you can spin up a TigerGraph Cloud solution. So what you'll want to do is in the top right here, click Create Solution. And here we have a bunch of starter kits. So each one of these is a pre-built out graph with data in it, with queries in it, everything that you would need in order to get started with any one of these particular topics. So we do have one for supply chain. So you would click Supply Chain Analysis next. And then, like I said, you can do this entirely free. So you could spin up a free tier instance. We can just leave all of this default, hit next. And then on this last page is where you'll actually need to change a couple things. So you could call this supply chain, just a name you need to give it. Initial password by default, this is TigerGraph, all lowercase. I'm just going to leave it as that for the sake of this demo. And then your subdomain is the actual domain where you'll access your TigerGraph solution. So we'll just call this one supply chain. Go ahead and click next. It'll give you a little overview, and then you would click submit to create your graph solution. I'm doing this the cooking show way, so we've already got one spun up. So we'll head on over to our supply chain solution. So when you do spin it up, you'll see it come up. It'll take about 5 minutes the first time it spins up just to get everything set up and loaded, but you will see it eventually turn green for ready. And then you can click these 4 boxes here and select Graph Studio, or you can see that within the URL here, we have supplychain.i.tgcloud.io. That is the subdomain that we created earlier for accessing this. So the first time you access any one of these examples, you will start off in the global view, and the global view really just gives you access to the global schema. So we can see here that the schema of our graph, we have products. They are used by other products. So these will represent our assemblies, our sub-assemblies, our components, things like that. Additionally, we have sites which produce those products. So this would be something like a factory. And those sites can also deliver to each other. So for example, as I was talking about earlier with the tires and the rubber, a site that makes the rubber for those tires might deliver the rubber to the site that actually makes the tires. So there's kind of that delivery linkage as well. And then additionally, there's stocking. So warehouses, how many tires are sitting in the warehouse ready to be sent out wherever they need to go. And orders just specify that someone has ordered those products. So that is the basic view of our schema and what everything looks like there, and kind of the idea of the graph that we'll be interacting with. So to head over to the actual graph, we'll just click on where it says global view. We'll select our graph name, which is demo graph here. And under our schema, we'll see pretty much exactly the same thing. You'll see that there's these little globe icons to represent that these are within the global schema as well. You could customize the schema locally. So I could add something here that only exists within this graph and not within the global schema. But for the purpose of these starter kits, we'll just be using what's supplied with us. And the last thing you'll need to do before you can get started, I've already done this, but you'll need to head to the load data page. And you'll just need to click the play button up here once it is available. And that will just load in all of your data for you. Just by nature, when you create one of these starter kits, the data is there, but it's not loaded in. So you'll just need to load it before you can actually do anything. So let's just take a look at what some of our data looks like. So this is an example of our graph layout, and I have just a small subset of the data selected here. But we can see that we're once again working with car parts and their relationship to each other. So here we have that example that I've been giving. These tires need rubber, and that rubber can be produced by either site 10 or site 11. And that rubber goes into tires, and those tires go into wheel sets, and so on and so forth. So this just kind of shows that example of what a more holistic view of our data looks like, how everything connects together, and how we can start seeing the reliance of different parts of our supply chain on each other. So this is great and all to be able to click around through this, but obviously that's not real world. You need some sort of programmatic way to actually analyze this data, and that's where our queries will come in. So we have a couple of example queries here that are included in the graph. This first one is going to check stocking. So this is for going back to our previous example. Say we wanted to make some car tires. Where are they? There you go. Or some car wheels. So this is a full assembly of a rim and a tire. But what I want to see is given how much of all of our components are available. So, we need rims, we need tires need belts and rubber, rims need, see what they need, ABS modules and aluminum rods. So we have all these things that are required to make a car wheel set. But how many can we actually make given what's actually available for each one of these things down the supply chain? So traditionally, we'd have to navigate through our supply chain. We'd have to check each table. We'd have to check the availability of each one. But here we can just pick where we want to start. So we want to start with a car wheel set, and I want to make 5 of them. So if we run this, we can again see now that connection between everything that is required for this car wheel set. It's again our rims, ABS modules, controllers, aluminum rods, and everything down the line. And we can see here that we also have quantities for these. These are just stored in our graph. So we have, those would be in stocking rather, but we check that. And if we go to our JSON results, we can see the entirety of what we need, as well as the cost formula for everything that will be put together. And we can see if we actually have enough of each quantity to do that. So we can see the consumed amount here. So now let's take a look at impact analysis. So this is kind of taking that same concept of, say, what happens if there's a natural disaster and one of the sites that produces rubber or one of the components for the vehicle is goes offline or is destroyed or has some sort of production impact where they're no longer able to produce the same amount that they wanted before. How does that impact everything up the line? And what can we see in terms of potential mitigation options that we have? So let's see what happens if site 5 were to be taken offline. So site 5 produces, let's just get a better look at this. Site 5 produces aluminum rods and steel rods. So those are 2 relatively important things for putting together our car. And we can see now that if site 5 were to go offline, those aluminum rods, those steel rods, and everything else included in this result would be affected by that. Take a look at our data set, we can just see everything here that has been affected. So that just gives us a good idea of, say site 5 goes offline, or let's try something like site 10. And we could see that as well. Site 10 just produces rubber. But if we remember, there's also another site that produces rubber. So that's why when we returned site 10, we only got rubber back, was because that's all that's affected, because we have this additional site as well, which can produce rubber. So let's see what happens. Actually, I haven't done this before, but I'll try it live. See what happens if we add site 11 in there, and we'll see, yes, we are infecting our rubber production. Now, price prediction is another thing as well. So while availability is important, price is also important. Say there is a rubber shortage and now rubber is more expensive. How is that going to affect the overall cost of our vehicle and the cost of each one of those sub-assemblies within it? So let's start with steel rods. And then we'll generations, and we'll not update. So steel rods before cost, I believe 0.1, and we're saying what happens if they cost 0.2. So we essentially double the cost of those. We'll see now that if we look at it, 1 second, just need everything to stop moving around on me. So if we take a look, we can see everything that's impacted by it. And we will also be able to see the updated cost formula now for each one of those components. So we can see steel rods here changed, used by truck rims. So the truck rims, that new price there, we'll see, is updated to reflect that change. So if I were to change this to something like 1, you'd see that our new price would go up significantly more. So that's how we can just kind of plan out the supply chain in the event of some sort of cost change. Got this query just lets us see the entirety of our supply chain, like I was clicking around before. So that's really kind of the basics of how you can use TigerGraph to help manage your supply chain, or graph in general, rather. There's no need for it to be any sort of specific. Obviously, TigerGraph being built in memory and having the ability to expand this way to consume huge amounts of data and store them and traverse them quickly, it lends itself very well for these types of real-time predictions. But the methods talked about here are in no way limited to any particular graph database. So given that, that's just kind of an example of how you can get started, what you can do, and how supply chains naturally lend themselves to graph data. It's sort of an interesting concept. You sometimes have to think about things a little bit of a different way than you're used to in order to fully wrap your head around how graph can be advantageous to you. But I can guarantee you that in most situations where you have more than one data set, more than one table, graph will help you gain better insights from your data. So it's pretty interesting because graph is, in a way, the way that our brains naturally think about data, these connections. We've put so much effort into labeling all these things that we see every day in our life. Words it's a noun, it's a verb, that's an edge essentially. Word is, of language type. We have all of these different ways that we naturally think about things with these edges, connecting them the way that they do. So it just only makes sense that we now represent our data in that manner. So it's a little bit of a paradigm shift to go from thinking in the SQL way or the relational way to thinking in a graph way. But it's something that hopefully through some of these examples and some of these slides here kind of representing the advantages of graph over a traditional database, hopefully that's something that you can start to think about and understand in a way that you can apply it to your own data sets and projects that you may be working on. So that is more or less it. And I would now open it up to any questions, should anyone have any.
If you have any questions too, just raise your hand and then we'll allow you to talk.
Yep.
I
Or
don't
feel
have
free
a
to ping them in
question,
the chat.
Daniel, but
Yep.
it was a great presentation. Thank you.
Oh, thank you very
Very
much.
helpful.
Yeah. As they say in military circles, amateurs talk strategy and professionals talk logistics, and logistics is really so important at the core of really every business. And as you may have seen lately on LinkedIn somewhere, that's logistics and supply chain is one of the hotter areas of study right now. So an excellent place to apply what you're learning right now in the MSIQ or the PhD program or the information science program, whatever your program is at UALR. There are a lot of applications to what you're learning to this particular domain, and it's a very fruitful and actually very intellectually stimulating field. So yeah, and it's one of our core use cases, along with or customer 360, entity resolution, and some others. Supply chain is as Dan made so clear, very amenable, very conducive to graph thinking. And speaking of graph thinking, I encourage you guys to, we can share some collateral with you, but there's this whole series of research or papers that I think Google popularized this phrase, think like a vertex. And there's a whole, this whole like graph way of thinking. And I encourage you to look at some of those papers to get an idea of what that really means. And I'm still working on it myself. I'm 4 or 5 months in at TigerGraph, and it is a different way of thinking, but think about the fact that, no more joins, right? Every join starts with a search, and you can obviate that entire step when you have edges connecting vertices already. So that's in some ways where we get the incredible performance available through graphs. But anyway, I'll stop there, but please ask us questions.
Yeah, Kyle, go ahead. Or Kylie, sorry.
Okay, can you hear me now?
Yes, yeah. Gotcha.
Okay, yes. So this is obviously fascinating as someone that designs relational databases and writes SQL. I see two challenges, and I'm hoping that you can kind of help us navigate the two cultural challenges that we'll have to face to implement this. So first of all, from a technical standpoint, those of us that design schemas, obviously, there'll be one set of mind shifts or paradigm shifts that we'll have to incorporate, and I think we're able to do that. But the users, the end users, the people in the C-suite who are used to looking at tabular reports, how do we navigate that? And what have you done in some of your other organizations to educate non-technical users to utilize a graph type of interface?
Yeah, certainly. So one of the great things is while I was showing off our Graph Studio interface, which allows you, has these great visualizations in it, everything done within TigerGraph. So from writing your queries to creating your schema to uploading your data, everything is exposed as a REST endpoint. So there's absolutely no need to ever touch Graph Studio, which I'm showing on the screen right now. You could spin up your graph solution and you could do everything entirely in code. So if you had a traditional system in place where you're already generating those tabular reports, maybe based off of, a bunch of SQL queries, you could keep that end in there. You just feed in your new data from TigerGraph and you've got exactly the same looking reports you had before, just with now all of your enhanced data. Obviously, when you're moving over to something new like this, it helps to kind of expand out what those reports look like as well, just because it's a new system and now there are all these additional insights that you can gain as well. So I guess the answer comes down to there is nothing preventing you from generating those exact same looking reports from your enhanced data within TigerGraph, but at the same time, it helps to, I guess, educate people on the data process. I know C-suite may not be touching the data all the time, but it's this graph way of thinking. It's not just this graph way of doing. So there's kind of this way now of when you think about your data in this new way, in this connected way, all the ways that things interact with each other and the ease of which you can see those interactions. Now you're not just thinking in terms of, how do I execute this? But rather you're thinking in the terms of what can I execute? What are the possibilities here? So I think that, I guess it's a long-winded answer to your question, but I think that the way to educate people on this is to really show them the difference. We're all used to something and we don't have, if you show me something brand new and I don't have anything to compare it to, then it's going to be foreign to me. But being able to say, this is what we had before, this is how we're doing it now, and this is what we're able to get out of it. I think kind of that side by side of, showing off that this is the advantage, this is the old thing, this is the new thing. So yeah, it's not the best answer, sorry about that. But long story short, you could, if you wanted to show them tabular reports, you could still do that. Otherwise, there's so many opportunities to build out nice dashboards. I mean, we have a bunch of this that we do where we have a graph backend for something like our C360 program. So who actually uses TigerGraph and where do they come from and things like that. So we're keeping track of all of that, and yet we're still presenting it in a your standard Tableau-esque dashboard location, because sometimes that's just, the way that we view data is we've been viewing data for a very long time, and we figured out a lot of good methods of doing that. So there's nothing to say that those aren't still good methods. I would say it's less of a question of how can we build a new way for people to understand things, and more of a question of what new things can we add to those traditional reports that we couldn't before, now that we're using Graph.
Also, too, we have a connector that integrates into Snowflake, or I'm sorry, into Tableau. And then also we have a whole demonstration that Dan's done a great job of how we integrate into Plotly and Streamlit and other types of products where they are the good visual display too.
Yeah, and just to follow up on what Dan said, it doesn't need any clarification or augmentation necessarily, but one thing that's worth noting about TigerGraph in particular is that we are there's different flavors of graph databases, and we are a typed graph database, meaning that we are schema first. So as Dan showed you earlier, he showed you the schema of the graph. And so, that is very relatable to relational folks. And so right there's that, that similarity. That's one thing. And the other thing is that, as Kaylee had mentioned, and Dan mentioned both, that while, things look the way they're being returned in Graph Studio, you can see that the JSON output and the output that would yield or issue from these reporting tools that Kaylee mentioned would all be tabular. So there's a lot of commonality. The benefit, of course, is the performance and the navigability under the covers. But as far as showing things that are similar or familiar feeling, there are those elements already. So the cognitive lift, I think can be minimized somewhat by, at least the schema aspect of it.
Yeah, certainly. And to kind of build off of that a little bit more, like Jeff said, like we've been saying, that wrapping your mind around the schema is kind of the hardest part of getting into graph, of this new way of thinking of things. But one of the great parts is just how flexible that schema is. We have data in that graph, and I want to add a new vertex type, maybe, I don't know what we want to call it, supplier. But I could go ahead and do that. I can add an edge now to our site, and we've created that edge. It's directed, okay, and we published the changes to our schema, and our schema is now updated. All of our data is still in the graph. It's just now if we wanted to add a supplier vertex, something containing, maybe the name of a supplier who is providing things to that site, then we're able to do that. So it's really nice in the way that as you're learning, you can just dynamically kind of change these things without having to worry about rebuilding everything around it. It's just, I want to add a new schema or a new vertex type and edge. Go for it. You're done. You click a couple buttons or type in some basic GSQL just to do that, and you're all set. So that's kind of really that flexibility of TigerGraph really lends itself to make it fun and easy to kind of learn and play around with. So that's just something that I find easy. When I was first learning TigerGraph, it was just like, how do I do all of this? And if I make a mistake, do I have to tear everything down and build it back up? And it's just, no, you just do it, and the graph will handle the rest for you.
So Dan, Kyle had a question about a follow-up question on how does importing data work?
Yes.
I'd like to address that.
Yeah, 1 sec for this to finish. Yeah. So when we're importing data, so this is pretty cool. Our visual way of doing this, I think, provides a great example on sort of how this all works. I also do want to say, before I get into this, we have a migrate from relational database. This is, like it says, it's an alpha, but you more or less import your database and we'll assume a schema from that. It's going to be a schema based on your relational data, but like I was saying before, with the ability to easily and flexibly modify that schema, it's a great starting point to just bring in your entire database, explore how it looks, and then add in those additional edges to really get the most out of your graph connections. But as far as importing data, there's plenty of ways that you can do it. So you either upload data files directly to the TigerGraph server and you link them like this. So this is our standard linking. So we can see here that we have a CSV file. These are the column headers and the first row of data. And then we can just easily link those to the attributes, or in this case, vertices when we're linking something together. So our site has a site name and a site ID. So we're just linking those together like that. And all of these files are just standard CSV files. But additionally, you don't just have to, we can also load directly through an S3 bucket. So if you have storage in Amazon, you can just select data from there. We also support direct Kafka loading. So if you have a Kafka stream and you want your data to be in real time, 100% go for it. And things that I've worked on in the past, there's been, they've just run cron jobs. So you have just a folder which gets filled with CSV files over the course of the day. Every morning, 2 a.m., run a cron job, ingest all of that data, and you're set. That's kind of an old-fashioned way of doing it, in my opinion, but really the point here is the flexibility. It's up to you how you want to get your data in TigerGraph. As long as it's in kind of a CSV format, then you're good to go. I believe we also have a JSON uploader, but I don't think I've used that recently, so I don't want to speak too much about that.
Thanks, Dan. Yeah, we do have our loader does support JSON. Just because of the nature of JSON, it's a bit wordier. Nothing's CSV is really the de facto sort of, relational export standard. I would encourage you to use that if you can, but yeah, we certainly can bring in JSON formatted data.
Yeah, so hopefully that answered your question. If not, let me know and I'll give it a second shot. Awesome. So do we have any more Any more questions? Any more demos that anyone wants to see? There's plenty of amazing things that you can do sort of with the graph way of thinking and how to put everything together. So it's one of the things that I find helpful is really just to kind of explore those starter kits or some of the tutorials and things, because a lot of it is just things that I never really even thought would be graph problems. You know, you have something that you're so used to doing it a certain way. Why think about doing it a different way? And then suddenly, you know, you're brought aware that, you know, we're combining all these different data sources and we want to see how they work together. And that's essentially the problem that graph solves. Is you can extract so much information from a data source on its own, but when you start looking at that data source within the context of other data sources, the amount of insights that you can gather just grow exponentially. And it's something that's really cool to see how, as you bring these things together, not only can you solve the problem that you're looking to solve, but a lot of the times inadvertently you end up solving problems that you A, didn't know existed, or B, didn't even intend to solve in the first place. So it's really cool to see and hear stories of when people take in, you know, ingest their data for the first time into TigerGraph, what exactly they're finding. Because it almost always starts off with, oh, we're trying to do X with our data, and then ends up with, we did X and we also did Y and Z and all of these other things. So it's really cool to see from the standpoint of kind of how much you can get out of something that you're so used to getting less out of.
Yeah, well said. As when it comes to data, the whole is definitely greater than the sum of the parts. And you can really see those emergent properties and all those things that you can do with your data that you really couldn't do before. So thank you again, Dan, for presenting this. Dr. Talbert or Kaylee, would you like to have any benedictions or final comments here before we conclude?
Well, I know this is going to be very useful for our current research project on the data washing machine. I know I already have some students, and which is basically an ER, entity resolution problem. And I'm also working with some other people where we might be able to use TigerGraph and to represent knowledge structures in a knowledge management kind of application. So this is all really very helpful. Thank you.
Thank you. Yeah, knowledge management is a great way for a great TigerGraph application, depending on what you're trying to keep track of. But that was kind of one of my first use cases, was breaking out. We were looking at medical claims and how to tell if medical claims are similar to each other. And we did that by breaking them out into, there's these ICD codes which describe medical procedures. So we had the ICD codes that each claim contained, and we broke that out. So now we had, you know, we could tell claims that had similar ICD codes, but those ICD codes are very specific. So like fracture of the left tibia and fracture of the left fibia, which are both, you know, bones on the left side of your body, those are two completely separate ICD codes. So then we took those ICD codes, we broke them down into the words that described them, and now you had a good linking. So if I said broke left arm, I now return all the ICD codes that contain those words, and then I can also return now all of the claims that are related to that. So I don't have to specify which bone in the arm was broken or which whatever. I can just say, find me arm break left, and here's everything needed for that. So definitely very cool for being able to do that type of stuff and relate those entities back to each other.
Yeah, so one final remark, when I promise we'll let you leave, is that, yeah, the great thing, you know, as Dan mentioned, you know, is bringing data together. And there's so many existing data sets, ontologies that you can augment your existing data set, in the ICD-9 classification scheme is one of them. There's another one for diagnoses. There's also, especially in the medical, you know, field, mesh. I mean, there's so many control vocabularies. So yeah, it's super awesome when you can enrich your data from existing data sets, and graph is just a natural way of bringing those two things together. So with that, I promise I won't say anything else. And thank you all for your attention today. And thank you, Dan, again for presenting to us. And thank you, UALR, for hosting us.
Yeah, thank you so much. And we had one more question from Abdus. Is there any book for learning GSQL or any other resources? And yeah, we have our whole developer community offers that information. So I will send out, I mean, Dan's pulling it up right now. It looks like We have a really great plethora of information to help walk you through the whole process. And our CTO, Aline, actually built GSQL, and he's a professor at the University of California, San Diego. And we'll share that with you in the follow-up email. And again, thank you all so much. We have another event that we're going to do October 22nd. And so we'll share more information about that as it comes up. Jeff's going to be presenting again. And if you have any questions, feel free to reach out to me or Jeff or Dan and ask the developer community. We'd love to see you try it out, give us your feedback, and we really appreciate everybody that attended. So thank you again so much.
Thank you all.
Thanks, everyone. Thank you.
Thanks.